Good day, class. In this video, we will continue to derive the inverse kinematic solution of our mechanical manipulators. So, for today, we will derive the inverse kinematic solution or inverse kinematic solutions of SCARA Manipulator, or the Selective Compliance Articulated Robot for Assembly. So, this manipulator is an articulated robot or articulated manipulator. Same as this. This is an articulated elbow manipulator. Okay, this looks like an arm, okay, with elbow. While this one is the SCARA manipulator. Okay. So for articulated manipulators, what we have the elbow down and the elbow up configurations. For the elbow down, we will use the positive angle to derive the inverse kinematic solution, while in elbow up, we will use the negative angle. Okay? You may choose only one of these two configurations, but remember, the solution for the elbow down is not equal to the solution of elbow up, but we may use either of the two solution. Okay? So we will choose the elbow down for the SCARA manipulator. Okay? So we will use the positive angle. While in articulated, we will use the negative angle. So we will use the elbow up. Okay, so this is a negative angle. Okay, we'll use here a negative angle for the articulated elbow manipulator. Okay, so to start our derivation of the inverse kinematic solution, we will redraw our SCARA manipulator into this top view. So this is the top view. At top view, okay, at top view, this is elbow up. Okay, so we will use the positive angle. So to make use of uh, our trigonometric functions, okay, for our inverse kinematics using graphical method, we need to find triangles. Okay, so in this given drawing, we have y sub 0 pointing upward. So at the from the end effector, we will have here the y sub 03. So under this square diagram is the y sub 03. Okay. So again, this is given. Y sub 03 is given because y sub 03 is a position vector. Next, along x sub 0 is the x03. Okay? X03. Okay, this is the x03. Next, so we have two sides which values are given. Okay, and this is a right angle. Okay, so we will find a hypotenuse here. So this will be our hypotenuse. Okay, from the end effector up to the base. Okay, so we will name this hypotenuse R sub 1. This is R sub 1. Okay. So because we have hypotenuse here, okay, we will find a way to solve for theta 1. Okay, for theta 1 here at the base. Okay, near at the base. So theta 1 is not the angle of the opposite side y03. So what we will do is to name a new angle. Okay, so this will be named as phi2. It will be phi2. Then inside phi2 is the theta 1. Okay, and phi 1. Okay, we will name this one phi 1. This will become phi 1. Okay, so we will have here phi 2 is equals to theta 1 plus phi 1. Okay? So if we arrange this to solve for theta 1, so this will become theta 1 is equals to phi 2 minus phi 1. Okay? So we need to find what is phi 2 and what is phi 1. Okay, so we will put this inside a box because this is an equation. Next, so we can derive what is phi 2. Okay, phi 2 will be equals to inverse tangent of y03 over x03. Okay, so this is our first equation to solve. Okay, because we can get phi 1, so we will number it 1. Next is we will derive what is phi 1. So phi 1, sorry. So this is phi 1. So phi 1 is inside another triangle, and this triangle is not a this is not a uh, right triangle. Okay? This is not a right triangle. This is a this is a what do you call? Uh okay, this is the sides of this triangle. The sides of this triangle is not equal, so we will use here the cosine law or the law of cosines. Okay, but we don't have yet the value for r sub 1. So we need a value first for r sub 1. So r sub 1 is the hypotenuse. So it means that to solve it, we will use y03 and x03. So we will use the Pythagorean theorem. Okay, so the y03 squared plus x03 squared is equals to r sub 1 squared, then square root at the other side. So this will be our formula to solve r sub 1. So we will number it as our second equation because with r sub 1, we can get phi 1 here inside. We can get phi 1 here. Okay. Now we already know what is r sub 1. Okay. So to solve for phi1, to solve for phi1, phi1 is equals to inverse cosine. Okay. Next, okay. So our sides are A4, A2, and then R sub 1. Okay? So because R sub 1, or sorry, because the opposite of V1 is A sub 4, so we will write here A sub 4 squared, then minus R sub 1 squared, and A2 squared. Minus R1 squared and minus A2 squared. So this is R1 squared minus A2 squared. Then the denominator will be negative 2 times R1 and A2. Okay? R1 and A2. So A sub 4 will be here. A sub 4 will not be negative because it is the opposite side of P1. Okay? So this will be our third equation. This will be our third equation. Our fourth equation is the theta 1 is equals to phi2 minus phi1. Okay? Because we already know now where to get phi2 and phi1. So we can solve now what is theta 1. Now, we need to solve what is theta 2. So, to solve theta 2, we need another angle, which is phi 3 here. Okay? Phi 3 here. We need phi 3 here. So why do we need phi 3 here? Because this is a straight line. Okay? This is a straight line from the base up to this side of theta 2. This is a straight line. But this doesn't look like a straight line, so I will fix this. Okay. Okay, this is straight line. Because this is a straight line, okay, and we have and our theta 2 starts from that straight line. Okay. And this is not theta 3, sorry. Theta 3 will not start here. Yes, theta 3 will not start here. Theta 3 will start at the side of A sub 4. Okay. Theta 3 will start at the side of A sub 4. Okay. So this is half of a circle, the rotation from this straight line. Okay, from the straight line up to the other side of this straight line. Okay, this is half a circle, so it means this is 180 degrees. Okay, so it means this is theta 2 or 180 degrees. 180 degrees is equals to phi 3 plus theta 2. So, if we arrange this to get theta 2, so this will be our equation. Theta 2 is equals to 180 degrees minus phi 3. Okay? So again, This is a straight line from the base, okay, where theta 2 came from. The other side is another angle which we named as phi 3. Okay, so from here to here, okay, because this is a straight line, it will create a half of a circle, and half of a circle is 180 degrees. So we come up with this formula: 180 degrees equals to phi 3 plus theta 2. Then to solve for theta 2, okay, we arrange this. So we subtract both sides by phi 3. Okay, now we get this theta 2 is equals to 180 degrees minus phi 3. Now we need to get what is phi 3. So phi 3 is inside a triangle which is not a right triangle. So we will use the law of cosines. Okay. So inside this triangle, we have three given sides, the A2, A4, and R1. So the opposite side of phi 3 is R sub 1. So our formula of law of cosines will look like this. This is phi 3 is equals to inverse cosine, close open parenthesis. Okay. So our positive will be R sub 1. This will be R sub 1 squared minus our two given sides. So minus A2 squared minus A sub 4 squared over negative 2. Then multiplied to our other given sides. Okay. So we will use this to solve for phi 3. Now, after solving phi 3, we can now solve for theta 2. So this will be our, how many? Our 1, 2, 3, 4. So this will be our fifth equation, and this will be our sixth equation. Okay, so now we can solve for theta 1 and theta 2. Okay. So this SCARA manipulator also has a prismatic joint. Okay, also have a prismatic joint. Okay, so we can see it at if we redraw our manipulator into front view, into a front view kinematic diagram. Okay, so we can see now our end effector. So our end effector is pointing downward at front view, and in this view, we can say that the given vector here, or the given element here, is the Z03. Okay. The Z03. So whatever Z03 is given. So this is Z03. Now to solve for D sub 3, okay, we can derive that Z03 is equals to A sub 1, positive A sub 1 plus A sub 3. So this is A sub 3. A sub 1, A sub 3 is links of elevation of our kinematic diagram. Then minus A5. So A5, the link of A5 will point downward, and minus D3. Okay, because the direction of our end effector is downward. So minus D3. So this is our starting equation. So to solve for D3, we will arrange this. Okay. So D3 is equals to A sub 1 plus A sub 3 minus A sub 5 minus Z0 3. Okay. So this will be our seventh equation. Okay. It will be our seventh equation. Okay. So now we have solutions. We have solutions to solve for our inverse kinematics. Okay. So we have now for theta 1, a formula for theta 1, for theta 2, and D3. So this is for SCARA. Okay. So for next video is the articulated elbow manipulator. Okay. So again, these are the formulas or the solutions to solve for the inverse kinematics of this SCARA manipulator using graphical method. So we have 1, 2, 3, 4, 5, 6, 7 equations or formulas. Okay. So thank you.